Hello, today I'm going over diffusion and osmosis lecture. So in this image, you see that there's some ink that's being dropped into a beaker of water, right? And over time, if we watch that ink, it's going to probably go down to the bottom, start spreading out, and eventually you're gonna see that ink spread throughout the whole column of water. Diffusion is the movement of particles from an area of high concentration to an area of low concentration. And that's what we see here. The ink is high concentration when it's first dropped in, and then as it spreads out, it's lower concentration. This process occurs because particles are constantly moving and spreading out over time. Diffusion does not require energy, making it a form of passive transport. When we drop this in, it's just the latent energy of the system that is moving those molecules around. We're not adding heat or anything else like that. It continues until the particles are evenly distributed, reaching equilibrium over here. So that's diffusion. Now we got to go into a little bit more about how particles are moving through diffusion and how they're getting into and out of cells. A concentration gradient is the difference in the amount of a substance between two areas. Diffusion always moves substances down their concentration gradient from high to low concentration. We see that here. First put that in, it's high concentration for the dye, the ink. And as it moves and spreads, it becomes low concentration movement to lower concentration over here. The steeper the gradient, the faster diffusion occurs. Once the gradient is gone, net movement stops even though particles are still moving randomly. So even in this last image here, the ink is evenly distributed. Well, those particles are still moving through that water, just like the water molecules are constantly moving, but it's going to stay evenly distributed at that point. It has reached an equilibrium in its concentration. All right, so osmosis. Osmosis is a specific type of diffusion that involves water moving across a selectively permeable membrane. So we're still talking about diffusion here, but it's specifically diffusion of water. That's what osmosis is. Water moves from areas of higher water concentration to areas of lower water concentration, just like on the last page. That's what we saw. In this image, what you're seeing is a membrane, selectively permeable membrane in the middle that only allows water to pass. The water is in the kind of like light pink here, okay? And then we have some kind of particles in here. Let's say it's salt. The salt is these purple spheres. Well, the concentration in this particular case, the water is higher concentration on this side than on this side. Because of that, the water wants to move from high concentration to a lower concentration. That's why it's going to move through these semi-permeable membranes, and you're going to get more water on the right side than you will on the left. But now these are equal as far as concentration of water. This is also a form of passive transport because it does not require cellular energy. So passive transport, no energy input. This happens automatically. Osmosis is especially important for maintaining balance in living cells. So osmosis is going to come to play, we're going to find out, in both plant and animal cells. Again, the movement of water. Facilitated diffusion is a type of passive transport that uses proteins in the cell membrane. So we've got our cell membrane here. In this orange, these orange structures are proteins that span from the outside of the cell to the inside of the cell. Some substances like glucose or ions cannot pass directly through the lipid bilayer. Transport proteins, that's what these are, these these large orange structures. Transport proteins help these substances move down their concentration gradient. So what we see is in green, we have these molecules that can't pass through freely. They can't freely pass through the lipid bilayer. So what they do is, just through random motion, they'll sit in these transport proteins. When they do that, there's a physical change to that transport protein. It changes its shape, allowing a passageway for that molecule to then enter the inside of the cell. As once this shape changes, it's actually going to automatically release this molecule to be dumped off in the inside of the cell, and it'll go back to its original shape. Even though proteins are involved, no energy is required for this process. Still passive. Okay. So we're talking some more about osmosis here. And this is when osmosis is involved in either making cells have more water, less water, or it's already equal. So this is movement of water because of concentration, osmosis. Solutions surrounding cells can be described as isotonic, hypertonic, or hypotonic. In an isotonic solution, so this first one, isotonic, the concentration of solutes is equal inside and outside of the cell. This means water moves in and out at equal rates and the cell stays the same size. That's what you see in both the red blood cell and in the plant cell. Water is flowing out, the same amount of water is flowing in, equal. The cell does not change its shape. Same thing with this plant cell. The amount of water moving in is equal to the amount moving out. It does not change the shape of the cell. Isotonic. It's kind of like just right, if you want to think about it that way. Isotonic conditions are ideal for many animal cells. Okay. Now, we talked about isotonic. We're going to talk about these other two, hypertonic, hypotonic. In hypertonic solution, there is a higher concentration of solute outside the cell than inside. All right, so hypertonic is this one. And it says there's a higher concentration of solute outside of the cell. So that means water wants to leave the inside of the cell because it's trying to equalize here. Water moves out of the cell, causing it to shrink. And we see this cell, because water's leaving, is shrinking up. It's shriveling. In a hypotonic solution, there is a lower concentration of solute outside the cell than inside. So now the water wants to move in to equalize things. Water moves into the cell, which can cause it to swell. We see this as much larger, right? It swell, or even burst if too much water enters. Okay, this gets us started on those concepts. If you have any questions, please let me know.